Hello. The moment you look at a number, you can easily tell whether it is greater or lesser than another number. However, in a geometrical figure, you will not easily be able to tell whether a line segment is greater or lesser. But for that, we have a theorem. Now, this theorem tells us that opposite to a greater angle in a triangle, you have the greater side, and similarly opposite to a lesser angle in a triangle, you have the lesser side, right? Thus, you can compare two sides in a triangle. Now, a triangle can be very easily built in within another figure, like suppose a parallelogram or probably a pentagon or say any other geometrical figure. Now, using this theorem, you will then be able to detect whether a line segment is greater or lesser. Now, this is what we are going to look up in this lecture. So, in this lecture, you will be able to understand how we detect inequalities in be it side lengths or be it angles, because the converse of the theorem also applies, that opposite to greater sides, you have greater angles, right? So as such, both of these theorems can be used side by side in order to prove that certain side lengths are greater and certain side lengths are lesser. So let's begin our chase with first trying to understand what the theorem is. Now the theorem goes like this. For this, first we will be having to make one triangle, right? So for that matter, let us consider that we have a triangle to be, say, something like this, right? It's a pretty large triangle, and you can easily see that there are certain sides which are greater and there are certain sides which are lesser. Now we will prove it by also saying about the angles. Now let's talk about this angle to be, say, an angle alpha, and let's talk about this angle to be an angle beta, where the different sides of the triangle are x, y, z, right? So the theorem tells you that if alpha is greater than beta, then this further implies that the side which is opposite to the angle alpha, that is yz, right, is also going to be larger than the side which is opposite to the angle beta, that is xz. Right? So this I will quickly repeat. Now here we have a theorem. The theorem is this, that if you have a triangle in which it is known that one angle is larger than the other angle, then the side which is opposite to the larger angle, like here we have yz, which will be larger than the side which is opposite to the lesser angle, as here we have beta to be the lesser angle. So the side which is in front of it, that is xz, is going to be lesser, right? So here, using this theorem, either this way that I've just stated or probably its converse, we are going to try and prove there are certain side lengths or there are certain angles which are probably unequal, right? So this topic thus is inequalities. Now if here you try out this sum, you will find that this theorem that I talked to you about is what is applicable. So initially I am giving you people little time for trial, after which I'll be discussing the sum with you people. So do try this out. Now children, make sure that you're sitting on a table and a chair such that there is no disturbance, right? And there is no electronic gadget nearby which is for certain to disturb you, right? And try this without the help of any other external aid, because these days all of those aids, right, like ChatGPT or probably any other artificial intelligence, has become so easy to handle, and especially with your generation. Okay, now children, coming over to the solution of the sum, we have a triangle ABC which is an equilateral triangle, and there's a point P which is on AC. So first we require to make this triangle. So let's say now we have this triangle again to be made, but at this time we require to form an equilateral triangle. So we'll be more cautious about trying to see whether all the three sides and all the three angles are equal. This almost looks like an equilateral triangle. Now let us name all of the three vertices to be, say, some A, B and C, right? And further, we've also been given that P is any point on AC. So we can consider this point to be, say, some point P, right? And further, as we have to prove BP to be greater than PA, we also require to join B and P. For that, now we'll be drawing a straight line. Okay, now let's say we have the straight line which is BP to be drawn, say something like this. Okay, so this is that straight line which is BP, right? Now as you see, we have two triangles formed here. One is APB and the other is PBC, right? Now what we have to prove is we have to talk about BP, that is this length, and then we also have to talk about PA, which is this length, right? Now in order to talk about these two, it's best if we talk about the triangle ABP, right? So this is that triangle which is ABP. Now we'll try and mark the angles as they are. If you talk about the angle at the top, it is 60 degrees, right? Obviously the angle at the bottom, that is angle ABC, is also 60. But if we consider this angle to be X, we can talk about this angle for sure to be 60 minus X, because we know that the sum of both of these, that is the complete angle ABC, will be 60 degrees. Now the third angle is to be written, that is this angle. Now for that, what you can do is, if from 180 you subtract the sum of the other two, that is 60 plus 60 minus X, you will get to 180, from which 120 is to be subtracted, and as minus minus will become equal to plus, so plus X is what you will have. 180 minus 120 will become equal to 60, and plus X, this is the angle which this angle is, right? And thus this angle BPA also has been measured. Now let us see the angle which is opposite to AP. It is 60 minus X. Right, the angle which is opposite to AP is 60 minus X, and the angle which is opposite to BP is how much? It is 60, right? And as such, this length BP in this triangle is going to be greater than the length PA. And since this length BP is there in this triangle, but obviously it is there in the figure also, so as such, in general, you can say that BP will be greater than PA. Okay, so all of this has been understood, but now it is going to be done as statements and reasons, like you write your theorems. And if you do it that way, only then you should expect that you'll be getting marks, right? So you can't cut short on this necessary entirety. So here on the left hand side, let us talk about statements, right? And on the right hand side, children, we'll be talking about reasons. So on the left hand side, you write what you did, and on the right hand side, you write why you did. Okay, excuse me. Now we talk about the first statement, and before that, we'll be talking about which triangle we are dealing with, that is in triangle ABP. So the things can be very clear. When we talk about a specific angle, it can be understood that it is actually in this triangle, right? So the first point is, you will say that angle PBC is X, and that's why you have angle ABP to be 60 minus X. So you will say that angle ABP is 60 degree minus X degree, and the reason is, you will say angle PBC has been assumed as X degree, right? So as angle PBC has been assumed to be X degree, as such, this angle ABP is going to be 60 minus X, because we know that angle ABC is 60 degrees. So further, you also write this as the reason. Angle ABC is equal to 60 degree, and here in bracket you can write equilateral triangle. Whatever you know, you should be writing it so that the teacher doesn't assume that you do not know. Okay, because you expect full marks and the teacher expects that you know it all, right? Okay, now next we talk about point number 2. So we talk about the side which is opposite to another angle that we require. So one is BP, right? So that is the one that we're going to talk about, and opposite to it we have angle A, right? So we will say that angle here, in accordance with this triangle that we are talking about, we can say that BAP, right? So we can say that angle BAP is equal to 60 degrees, right? And here you will write the reason as angle of an equilateral triangle at any vertex is 60 degree, right? And you know this. Okay, now that we have both the angles that we require, we can now talk about the sides. Now we can say that BP is going to be greater than PA. BP is greater than PA, and the reason is, you will say that angle BAP opposite to BP, right, is greater than angle ABP, right, which is what? Which is opposite to PA, right? So here, children, if we have ABP, right, you have this angle opposite AP, right? And that is what we've written here. And the other angle that we talk about is angle BAP, that is this angle, and we find that this angle is actually larger, and as such BP is going to be greater than PA. Now here, children, you also require to write the theorem, right, comma theorem, because that is the main aspect which has helped you to prove this. So the teacher expects that the theorem be written here. Okay, THEOREM, right? And the theorem goes like this, that side opposite to greater angle is greater, or you can even say larger, right? So this is the theorem. Now all of this, children, I will just quickly revise with you so that if you have any speck of doubt, all of that gets cleared. So children, the question you've been given here, if ABC is an equilateral triangle and P is any point on AC, you have to prove that BP is greater than PA. So what you do is you first make an equilateral triangle, right, and then you make the point P, which is any point on AC. So on AC we take a point P here, and then as BP is required, we joined B and P. Now children, we talk about this small angle assumed to be X. As such, this angle becomes equal to 60 minus X, right? And further then we talk about the statements in triangle ABP, because that is the one in which we are concerned, because we will talk about these two lengths which are actually in this triangle, right? So first we talk about angle ABP, and we have this angle to be 60 minus X, as this angle PBC has been assumed to be X, right? So this angle will become equal to 60 minus x. Now for the next, what you do is further we talk about angle BAP, which is going to be 60 degree, as any angle on an equilateral triangle's vertex is 60 degree, right? So we write about that this angle is going to be 60 because it is in an equilateral triangle's vertex. Now children, next we talk about comparing the sides. So we say that the side which is opposite to angle A is larger and the side which is opposite to angle ABP is lesser, right? That is because the side which is opposite to AP has an angle of 60 minus x, right? Like here ABP is this angle which is opposite to angle PA. Side PA. Okay, so this angle is 60 minus x, okay, and the other angle is 60, and that's why the side which is opposite to it is going to be larger, right? And then after that, underneath you can also write the theorem that the side which is opposite to the greater angle is larger or is greater. So is all of this clear? So this is how in sums on inequalities you will somehow or the other take all the sides or the angles which are to be compared in a single triangle, and then using this theorem you'll be able to prove it. So I hope you've been able to pick up good amount of confidence. Further, if you want more confidence, you have a form link, right, which you can fill up and you can tell me about the topic which you want more strength in. I will provide you some strength for sure, be it through a live class or be it through some of the self-paced courses. But make sure that you tell me what your problem is, because I'll make sure that when you tell me your problem, I'll help you out. So bye, stay hooked, keep learning, and never be having this feeling that maths is something which you can't conquer. You can conquer anything. Just let me know. Bye.